not recording the meeting. How that is not supporting, or how that is creating the issues. So I hope everyone would have heard at least the term yarn a few times in my training or outside also. Right?
Yes, we only heard about it, but no idea what it is.
Okay. So yarn is Hadoop 2.x architecture. That is the latest one in Hadoop. So as a name, it's the full form is yet another resource negotiator. So it tries to resolve all the remedies which were there with the classic MapReduce or Hadoop Consortium architecture with the scalability. So the major issues were with the scalability of 1.x architecture. How that was, I'll just talk about that. And also it's a more general purpose architecture, so that helps not only the MapReduce but also other things to fit into this architecture and use it. So even a Shark can use this architecture, or your any other things can use this architecture to run their programs into your HDFS file system. So everyone remembers this thing? What we discussed over here: client, job tracker, task tracker creates the task, and how this thing was working.
Yes.
Right. So the problem with this, I'm sorry, the major problem with this person is all of the work or all of the monitoring is done by this job tracker. Now, if say this node of job tracker goes down, there's a problem with my whole system. Agree? Although we can keep it up, we can create a backup, but still if it goes down, there is a problem at the time. Moreover, if it's managing all the jobs which are running in my cluster, you can think of overhead on this job tracker, how much work this job tracker is doing. So that was a major issue with this approach, that all the monitoring and bookkeeping work was handled by one individual person, and that was that became overhead when we do scaling of cluster in very large scales. So that was a major challenge with this approach. This job tracker was a major guy, and when there was large number of jobs in this pool, there were issues with the scaling of this job tracker thing, or monitoring everything by this job tracker. So these are the limits with that approach. So maximum cluster size which could be attained with this architecture was 4,000 nodes only, and maximum concurrent task with this approach could have handled based on the vertical scaling and things like that was approximately 40,000. And after that, there was code synchronization issues in the job tracker, and people were not able to achieve scalability more than this with this kind of architecture. Although the figures are too high, but in this world, it's nothing. So moreover, as I was talking to you, there was single point of failure. So still one person is missing. Umesh is not yet joined. So single point of failure, as I was just talking about, failure kills all queued running jobs. Jobs need to resynchronize and restart. If the job tracker node need to be restarted, you can think of the complexity in the system. So any questions, any doubts over here before I talk about this new architecture? Everyone agrees, right? Agrees. So what happens in the new architecture is there's something called resource manager rather than your job tracker. There's something called load manager rather than your these guys task trackers. And there are containers which run your real jobs. So these are your, again your kind of JVM instances where your real things are running up. And there's something called application master, and application master itself runs in the container only. So the duty of your job tracker is divided in at two places. One is at resource manager, one is at application manager. How that is divided? Resource manager now do not do all the bookkeeping activities of your job. It just does the resource management of the cluster. So it just manages where are the resources available in my cluster, who can give the resources to my job. That's all. Nothing more than that. It does not keeps on talking to these task tracker guys. What is the status of the job? Is it run successfully or not? Where is my job currently? If the job has failed, where to send it again, and things like that. So it don't do all those things. It just manages the resources across the cluster. And for each new job, whenever I start a new job, there is an instance of application master which is triggered. And this application master does all that bookkeeping activities for the job. So for each new job, a new application master is triggered, and that application master monitors all those things what your job tracker was doing over here. So here job tracker was doing two things. If you can recall, it manages the resources across the cluster as well as monitors the jobs across the cluster. So now the resources monitoration part is given to a resource manager. So it just monitors and figures out where the resources are available, nothing else than that. And the monitoring part of the job is being handled by the application master. And the beauty is for each new job you trigger in the cluster, there's a new instance of application master triggers up. So if say a job X is running up and here is application master is running on this node, and if this node goes down, there's no other job which has been hindered, only this job which has been monitored by this application master would get hindered. And the scalability, you can think of how highly my system could be scalable, because I keep on adding the nodes, and application masters could be spooled on any data nodes. Now, what are these node managers and containers? So, as I told you, containers are nothing but the containers are your instances where your instances are running. So, application master itself runs in a container only, and your real jobs which are running over here, these tasks, they are also spooled into containers only. And the node manager is nothing. It's similar to your task tracker. This node manager manages the node. So when resource manager wants some resources, or some application master need to be triggered on some node, resource manager talks to a node manager, tell them that this is what need to be done, I need the resources, or this is need to be triggered, and the node manager will do the corresponding task. So make sense? I'll again show you all the things, but does it make sense now?
All these node managers run in individual data nodes, right?
Yes, one node manager, each data node.
Okay. So resource manager basically manages all these node managers?
Resource manager, as the name itself says, it just manages resources across the cluster.
Resources across the cluster. Okay.
Like which data node has more CPU, which data node has
yes.
more room for another task, or which data node has the data, whatever.
Yes.
So I have a question. So
I'll go ahead. Yeah.
Yeah, this model removes the constraint on the number of tasks, which is 40,000 upper limit with that version 1, right? Because it's spawning the application master on the data node where resources are available. So now, how does it address the 4,000 node limit on this?
So this 4,000 node limit was again with that problem only. When the number of nodes become high in the cluster, maintaining the job across those nodes by a single entity was creating issues.
Okay.
So now we don't have to maintain the jobs which are spooled across the nodes. That is done by individual application masters.
Okay. So what happens when the data node containing the application master goes down? How does the application again restart?
Okay, just wait for. I'll talk about that. Just wait.
Okay.
Just for a minute. I'll talk about it. So okay. So this is how this everything happens, and this will answer your question also. Sorry. So you can see my screen, right?
Yes.
Okay. So what happens over here is you as a client run your job. You send a signal, or basically you get a new application ID from your resource manager. Previously you were getting it from your what do you call that, job tracker. And then you put your code, or your logic or jars into your SDFS, and you say submit application. So what I do, Hadoop jar minus my jar name and those things. So this is what is happening over here. This resource manager starts a app master container. So basically this is your application master. So for that, it communicates with any of the node manager. Node manager triggers the application master, and this application master will basically maintain or everything running in the basically to run your job. So the same thing happens over here. The application master gets the number of input splits from your SDFS, and again contacts your resource manager. Resource manager for the new resources which it want to trigger your individual tasks which need to do the real job. Resource manager gives the resources to this application master. Application master communicates with those corresponding node managers, and node manager will basically trigger those containers which will be triggering your map or reduce jobs inside your data nodes, and they get the resources, or the logic from SDFS, and trigger that logic on the corresponding data node. So it's very much similar, only few things change. The application master and the node manager, application master and the container which is spooled on the node manager. So I'm just coming to your part also. So job tracker responsibility is divided into two things: your resource manager and application master. Job scheduling and monitoring, one per application. The application master negotiates resources from the scheduler, tracking the status and monitoring the further progress. Application master itself runs a normal container. Now your task tracker is now that is handled by your node manager. Now new per node slave is responsible for launching new applications in the container. That is what I was talking about, and these things I've just talked about: your client, the resource manager, node manager, application master, SDFS. And this whole flow is described over here in detail over here. Now, I think Umesh was asking that question, what will happen if this node goes down where application master is lying? Or who was asking it?
Karthik.
Karthik. So Karthik, what happened in 1.x architecture when your job tracker goes down?
So if the job tracker goes down, then all the jobs are done, right? So we have to restart everything when the job, whatever that name node is started again, right?
Yes. So now what we have achieved over here is if this data node goes down and if application master running over here will go down, so only that job will go down, none of the job get hindered.
Right. But does the job get automatically routed to another node, or the client has to restart the job?
A job as an entity was being triggered by application master, so that would not happen. Similarly, the job tracker, if job tracker have gone down, nothing would have happened for any of the jobs here. Nothing would have happened. Nothing will happen for this job.
Okay. So the client will be notified that it failed, and the client has to restart.
Yeah.
Okay.
But now only one job is hindered if some data node or some node has gone down, rather than all the jobs getting hindered if the job tracker node goes down.
Okay. And how about the task? So if the task itself goes down,
so that everything is taken care of by application master. So if this data node goes down, then the application master knows because it's directly communicating with this name node on that frequency. So it will tell another data node to trigger this. So those everything happens over here also.
Okay.
So this is what I've described over here. The client submits a MapReduce job. The resource manager, the job interacts with the resource manager, acquires the application ID. Job code is moved into your resource SDFS. I think I've told this. The replication factor of this thing is pretty high in the cluster as compared to your default replication factor of 3. That is by default, I think 10. And I hope you understand the logic and reason behind that. The job code submits the application. The resource manager chooses the node manager.
Sorry, can you repeat that? Whatever you are saying, replication factor. What is that?
Your logic or your the jars are replicated by a factor of 10 rather than by default 3. And why, you know?
No.
Okay. So your job or your logic need to be referred by n number of data nodes. So if that is nearly available or highly local, that will make my jobs to run faster. So that is the reason the replication factor of those logic or the jars which you place in to trigger some job is high as compared to your data replication factor.
Okay, so you're talking about the job related jars and input files basically.
Not the input files, not the input files, only the jars. So when I say jar, Hadoop jar minus jar name, so that jar.
The code package. Okay.
Yeah. So this is acquire job resources. So this thing is faster in the cluster because if it will be available locally to the data node if the replication factor is too high.
Okay.
Or near locally. I won't say locally, but near locally or on the same rack or on the same data center at least on big clusters. So that's a reason.
So it doesn't affect the other actual data, right? That replication factor is still 3.
It's still 3. That again is configurable, but by default it's 3 only.
Okay.
So where else? So resource manager chooses the node manager. Node manager allocates a container for the MapReduce application master. Application master grabs the required resources from SDFS, and then again negotiate with the resource manager. Got another node managers where it need to run the real job, and it creates those things inside the container, and the yarn executes a map and reduce task. So this is the whole flow. very much similar to the previous one, but few drastic or major changes. Your job tracker is divided into a resource manager and application master, and the task tracker is basically a node manager, and your all jobs are triggered inside the containers, including the application master inside the container only. Any other questions on this thing? Okay, I'll assume no. So now I think someone has also raised one of the question in the previous classes. I am not able to recall that question, but was related to this. So when you will run, your jobs on your local VMs or on your cluster, and if the job is very small, sometimes you will see the upper mode is equals to true or false, something like this. In one of the line it is printed. So what is that? So now what happens is in the yarn architecture, the job is small. So right now the VMs on which we are the sandboxes which I've shared with you are all on this yarn only. So everything you would see is related to yarn only. So if the job is small, the application master may choose to run them on the same JVM instance as itself. So here what it's trying to do is based on how big your job is, application master would think of that would it make sense to communicate with the resource manager, negotiate for the resources, then go to the node manager and ask him to spoon another container. All this bookkeeping activity, does it make sense for a smaller job? Rather, will the bookkeeping activity will take more time, or running a job locally would take lesser time as compared to the bookkeeping activity of all this thing. So if your job is very small, it will, rather than doing all this thing, negotiating with the resource manager and the corresponding, node managers and creating new containers and things like that, it spools the job locally, and that is called upper task. So if the job is small, the application master may choose to run them on the same JVM as itself. Application master judges the overhead of allocation of new containers, running tasks in them as outweigh the gain to be had in running them parallelly compared to running them sequentially on one node. So this is what it checks. If I run, say there are three tasks which need to be triggered for my whole job, and if I run them sequentially on my local node, will that be faster up, or will doing all this thing, negotiation and all those things and creating on some other data node will be faster up? So that it figures out those things, and based on that it might trigger your hour task, which is nothing but all your work is done on the same application master rather than spooling new containers for that job. And this is a real difference from MapReduce 1, where whatsoever can happen, your job tracker cannot have never have run your logic, because job tracker was not that much free to run your real logic. And your job running on a single container is said to be hoverized or run in our task. So yeah,
Miraj, just one question.
Yeah.
So how does the application master judge whether a job is small or?
Okay. Yeah. That is what I'm talking on the slide.
Oh, okay.
So again, these things are configured. These are the default one, but you can always configure these things. So these are the default configurations. Anything less than 10 mapper can be appraised with only one reducer. So 10 mappers and one reducers, you can say about the job. Input size is less than the size of one HDFS block. So these are the configuration things which you can configure, but these are the default ones. And how to configure them? These are the configuration properties. You can set them while running your MapReduce job or directly into the configuration files. As I told you on the Ambari UI, I'll just again tell you them. So Ambari UI now will make more sense to you. So MapReduce or job.our task map max maps, max reducers, max bytes of my data. So based on these parameters, it would trigger your hover job or not. And I can even disable the whole hover task by enabling or disabling the hover task.
So yarn is basically complements the foundational MapReduce.
Yes. So this is yes. So this is how the whole. Okay, 1 minute. You raised one thing. Just I'm pausing my screen. Let me open one more picture that will give you more. Just a minute.
Okay.
Where is that called? So is my screen visible?
Yes.
Okay, so this is what is happening over there. You have a distributed file system. On top there is we have MapReduce.
Hold on. We are still seeing the presentation. What qualifies a small job because you paused, I think.
Okay. It would refresh.
Yeah, now we see that.
Yeah, now we can see.
Okay. Okay. So this is how your system looks like. You have HTML file system. On top of it, we have MapReduce framework. Pig, Hive, and Scoop use this MapReduce framework to interact with your HTML file system, and your ETL tools and BI tools or reporting tools interact with these things to get your real data. And this is how your with yarn looks like. So this is yet another resource negotiator which your MapReduce framework would use, and there's something called Tage which is in parallel to MapReduce. This is the latest introduced. I am also not much sure about this architecture, but this is very fast. I'm using this architecture. This is claimed to be 100 times faster with as compared to your MapReduce. And these Pig and Hive sit on top of MapReduce or Tage. So Pig, Hive over Tage is 100 times faster. That is claimed by the industry. It's not exactly 100 times, but I found it really much faster. And now Hotelmix is also planning to integrate Pig with Tage also. And this is on Yarn, your SJFS also sits up. And in parallel, you have your Scoop, Flume to get in the data. The Nox is for security in the cluster. Ambari and Falcon and Uzi are either for cluster management or workflows. And if I look into the deeper in the system, it looks something like this. So these are different components you could be hearing up in the MapReduce world. Scoop, Hive, Uzi, Mahout, Edge Catalog, Impala, Ambari, Avro, Chukwa, Flume. And let me show you how the real flows happen. Just a minute. Okay. So when you will be designing up the system, this is how somehow your system would look like. So these are something for my clients. So when you will be really designing your SDFS system, this is how your system would look like, and this is where everything would set up. Sorry. You would be getting the data from different sources, queues, API management, different NoSQL DB, SQL DB, this plug, Internet of Resources, and things like that. that will push in your data to your Hadoop cluster. On that data, you might be doing real-time analytics, you might be doing batch analytics, you would have security things. So your security could be achieved by SSO, Kerberos, or Knox. Then your your base HDFS would be running up your daily jobs, which would be doing a batch analytics on your data. This data could be archived daily. This data could be deleted also, some part of the data after filtering. You might be running some machine learning algorithms on the data for different reasons, or to find out deeper insights on the data. And your different applications would be interacting with the system directly or with the application layers. When you will be really designing a system, you might design the application layers in between also. So you might expose some things on a system by data as a service, or with the help of APIs, or directly Hive integrations or some other integrations. You might implement Elasticsearch and things like that on a system to make it more scalable, and with particularly integration with these things would be easier up. So this is how you basically system looks like, and your yarn sets up. So as you raise that point to where the yarn sets up, so I just open this slide. This is how yarn sets up. Any questions on this part before I move back to our yarn thing?
No.
Well, I'll talk about these things. There's a lot of things in this world. We can't talk with each and everything, but this is how your really data, each day data. We have not talked about this big Hive thing, so this will not make much sense. So, but as you have raised the points, I'll just open this thing. So this is how your real application workflows happens daily. Your Uzi workflows are triggered each day. They will trigger your scoop jobs to get in the data, or some Flume jobs to get in the data. That get in data might be filtered or processed with Pig and Hive things. On top of that, you would be creating a data warehouse, which would be which would be accessible by the outside world, and this data warehouse would be used by your real analytics or dashboarding tools. Okay. Oops, I'll close this. Okay, so this is how the updated status happens. Everyone can see the old PPT, right? Map reduced job submission.
Yes.
So similar to the previous architecture, here the updated status happens the same way as I was telling you. It's keep on pooling for that, and just keep on sending the updated status, so that application master knows which of my containers are running fine and which are not running. If they are not running, I should spool a new ones and things like that. So these are few more differences on your 1.x and 2.x. So there we had something called node, name node, but in 2.x we also have a node node, but there, as I was telling you in the slide, there's something called secondary name node, which copies, or which is a kind of replica of your name node. But here we have something called checkpoint node. There is nothing called secondary name node. but here we have something called checkpoint node. And the data and everything is synchronized between your name node and the checkpoint node with the help of coordination things which are done by your zookeeper. And the beauty with this system is, or 2.x is, if your name node goes down, there is no manual intervention which is required in the cluster. Automatically the checkpoint node is enabled, and that has your near-time replica of your name node, and nothing in my cluster is affected. However, over here, we had a secondary name node, but there was a difference between the name node and the secondary name node at a given instance of time. That might be a few seconds also, but there was. Moreover, when your name node goes down, your secondary name node needs to be started up manually. Here, everything is taken care in the cluster with the help of zookeeper. And the name node is now called checkpoint node, which contains your replication of the name node. So here we have MapReduce2, that is yarn, and this was present task managers. Okay, so all of you have not looked into the configuration files, but let me talk about them. I'll show you these things also. So here, so all the things in the Hadoop cluster, as I was keep on saying, are configurable. So the core related configurations are there in core.xml. Core site.xml. The SDFS related configurations are there in SDFS site.xml. So these are some differences in 1.x and 2.x XML file names, or then MapReduce related configuration are there in MapRed site.xml. And in 1.x there was nothing called yarn. So there's yarn also in 2.x. So yarn related configurations are there in your yarn site.xml. I'll just show you them on the Ambari UI in a minute. There's a little difference on the ports also. So your name node runs on a 5070 only, 5070 only. MapReduce one is not there, but your yarn is there. Yarn runs on an 8088, and your yarn MapReduce job history server 1988. There's some difference in your jars also, which we were importing in your Eclipse. So here are the differences in the jars and how to start those things. I have detailed about them. You can look into these things. The SH files or these things has changed. Let me show you the Ambari UI, and now the Ambari UI would make more sense to you. So give me a minute. Let me open the Ambari UI. Okay. My server is down. I'm just putting it up. It would take a minute or so. So by the time it's getting up, any questions on the yarn or anything related to that?
So the Hadoop specific configuration file, are they on the sandbox?
Yeah, they are on the sandbox. I'm just opening the Ambari UI only to show those things to you.
Oh, okay. So Ambari UI is mostly for administration.
Administration, yes. So now the problem is you can go into your sandbox Unix world also, basically log into your sandbox and change it manually over there. But when say your cluster size is 1000, So you can't go to 1000 nodes and change these XMLs on the 1000 nodes.
Oh, yes.
So always try to change them from the Ambari UI. So you change it on the Ambari UI, Ambari will take care to replicate it across the cluster.
So, but in our test environment, we just have one node that is everything, right?
Yeah. So here you can change it, but again, why to go over there and change it manually? There's a beautiful UI available, but I'll tell you. So you can change it over there also.
No, that's fine. I mean,
Yeah.
definitely UI is preferred.
So just a minute, let it open. Let the cluster, let the sandbox start up.
Okay.
So keep on reading about this word. Actually, now, I am talking about only the majorly used things like pig, hive, spook. There are a lot of things happening in this area, and in sessions we cannot cover all of these things. Every day there is a new technology which is coming up in the Hadoop world, and the world is moving very very fast. So keep on reading to keep yourself updated. Wherever you find new thing, you can ask me. I might be aware of that, but I am also not sure if I am aware of all the new things. But yeah, as we are using a lot of new technologies, so I am aware of, but still, there's a lot of new things happening in the world. So nowadays people are moving to Spark. Spark is highly used and highly demanded in the industry. Spark gives you in-memory processing, and that is very fast as compared to your native Hadoop. So Spark and Scala is one of the deadliest combination used in the industry right now. And people have now started using Spark over Cassandra or rather than using SDFS also due to different reasons. So my cluster is up. I think Umesh did not join at all today.
Yeah, I don't have his cell number. Otherwise,
I also don't have Umesh number.
yeah, he just gave his personal email. That's it.
Oh, what happened? We're staying so much time. Okay, it's up. So the password is admin and the port is 8080. Oh no man, I have started 2.2. Okay, not a problem. So here is Tom also and everything also. Okay, I started 2.2. You on your cluster you won't say all these things. I have shared with you is 2.1. I have started I think 2.2 right now. So okay, you would see few more new things. So Storm is used for real-time processing. So if you go to see, I have clicked on SDFS and I clicked on config. So see, here we have all the configurations which you can think of are related to SDFS. Secondary name node checkpoint directory, maximum, name node maximum, new generation size and things like that, data node related things, your replicant factor, blocks replicant factor by default, block sizes, and heartbeat interval, port on which it's running, all those things, all related to your SDFS. And here we have both the things, code site.xml, which is your code to the cluster, and your SDFS site.xml. So you can add a property always over here, otherwise the default properties are taken care of. So if you want to change any default property, you can always click add property and add the new property over here. So
what is the, sorry.
Yeah.
What is the username password? Is it admin?
Admin, yes.
Somehow it's not.
Okay. Yeah. So makes sense. Yeah. So what you have to do is go to 127.0.01 and colon 8000. That is a UI. Press enter.
Okay.
Google. Nice logo. And over here your Ambari would be disabled. Make it enabled.
No, actually it is enabled.
No, the enable means the button is enabling it. You have to click on the enable, then the disable will be enabled. So right now you have the enable is enabled. You have to make disable as enabled.
Ambari, no. Okay, so I enabled it earlier.
Okay, you enabled it?
Yeah, so I see the message is now I disabled and I'll enable again. So let's see, it says enabling Ambari.
Yeah. Now try that 80 port.
Now try that. 8080/login, right?
Not required, just 127.0.0.1 colon 8080 would work.
Oh, colon 8080. Okay, so it pops up a dialog with username and password. So admin, it says authentication required, and the server says XDB. I don't know what it is.
Sorry. It will not pop up anything. It will ask you on the same same web browser. It will not pop up anything.
No, it is popping up a dialog with username and password, and there is a message that says the server says XDB.
So I think Basha, your some other thing is running on port 8080. Can you check your net state? I think there's something else. Yeah, there's something else which is running on your port 8080.
Oh, how do you know?
So what you can do is go to this your putty and check on which port this Ambari is now enabled. You can say Ambari-server space status. That will tell you the Ambari server is running, and that might also tell you the port, but I am not 100% sure. So, or you can use netstats to check there's some other thing which is running on your PC on this port 8080 and kill that thing and restart your server.
Okay. So it is possible that something else is.
Yeah, as you are saying, some data, so something is running on your. So netstat minus p or something would give you the port number and what is listening on the port.
So how do I change the port number of this Ambari? By default it is 8080.
Yeah. So it would have started on some other port only. 1 minute. So just a minute. AM. Let me check whether that gives the port number. MBRI high.
There might be some local that is running on that port.
Just a minute. So whenever something comes to the admin part, I'm not that good. Just a minute.
That's okay, Miraj. It's okay. I can figure it out.
Okay, I'll also cross check where to change that part. I'm also not sure. I will check. But you can just say a status that will give you the status whether that is really running or not, or you can do ps-ef grep on your that thing to check whether the Ambari is really started or not prior searching for the port. So here we have everything related to your HDFS and things like that. And just give me a sec, just a sec. So we have everything over here related to your SDFS and things like that. And the core site.xml will have your things again related to your Hadoop. Okay, so let's open the yarn thing. So are there still issues with my voice now, or it's fine now?
Yeah, it's fine now.
So I think there's a particular issue at that time frame only. So that is what I was saying. In other classes also I do not see any issues. So today also there is no issues. So I think that particular time frame only there's some interference in the signals of the Wi-Fi. Okay, so the yarn has all your configuration related to yarn. So I'll just click on yarn. So here you will see all those things also, and the other related things also would be somewhere here only. Let me. Upper related things would be somewhere here only. So if it's not configured over here, the default one would be taken care, and all the yarn related things would be here. So you can see your resource manager, your node manager, your application timeline server, your yarn schedulers, and the yarn directory and all those things related things, where your resource manager is running, where your different things are running. Then here you can add yarn related things, and this is log portal properties. So I'm not going into detail of these things. Those are very much related to administration related things. But if you have to change something someday, and this is related to your MapReduce. So the JVM instances, how much is the memory given to your different JVM instances which are triggered, and MapReduce sort spill percentage. So this is a percentage of spill when your mapper phase is sending the data to the reducer phase. If your memory is full by 0.7%, it will spill to the disk. Shuffle, merge, and all those things which you were talking about, and the one. So these are the things which you would be using up. So 1 minute. Container size is coming. So yeah, sometimes you might be, facing out of memory issues when you are running your big MapReduce jobs because your data on a single mapper is going large or things like that. So there you might be changing some of the things in the cluster. Other than that thing, all are configuration related things which your admin people might be taking care of. So that those could be configured with the heap sizes. What is the maximum heap size? And there are two more things which you can change. Okay, that will be on over here. The memory need to be given to your mapper, and the memory need to be given to your reducer. Where is that gone? Yeah, here are the jobs. MapReduce reduce jobs, and similarly there is a MapReduce map jobs. So these are the maximum memory given to your mapper and reducer when the JVM instance initialized. So minus XMX is the property with this JVM initialized. So these things you can change to handle the issues when you are getting in out of memory kind of thing on your MapReduce work. So these are the JVM parameters which are given before your container is really initiated. That container is again a JVM instance. So with these parameters, those containers are initiated for a mapper and reducer. So these things you might have to change sometime to check your MapReduce word if you are facing out of memory kind of issues in your big jobs, or if your data sizes are high as compared to the container sizes. And then we have configuration related to all the other things. Ganglia is used for monitoring the cluster. Zookeeper is used for coordination across the cluster, as I was telling you. But it will not be justifiable for me to cover because I also not know most of the things on the Numbari UI. Falcon is again similar to your Uzi. It's latestly is introduced in Hadoop 2.2. So this thing will not be visible in the in your Numbari UI. This is 2.2 cluster which I opened by mistakenly right now. Started displaying right now. So Falcon is similar to your Uzi, but it's a workflow which helps you to do a workflow across your clusters, to create workflows across the clusters. I will talk about in next session. And pig and scoop, so configuration related to your pig and scoop, and you can do a start and stop of everything from here. So now if I show you that thing also, that will make more sense. Just a minute. So now this thing will more sense to you. So now the resource manager UI would be okay. Right now there is no job which has been triggered. So if it's maintaining some history, I'm not sure. So okay, when I'll run the job, I'll show you. Now that will make more sense to you how the application manager you can look into the logs of each application manager and the resource manager, which are application manager and the containers which are triggered for our job. You can go into each application manager and look into the detail about those things. Although I've told you that thing previously, but now that will make more sense. So I just wanted to tell you that thing. But right now we have not triggered any job. So when I'll trigger some job, I'll show you the thing. So although I've gone very fast on the Mari UI, but if you have any specific question, I can help out. But I cannot really help into the administration related things. Definitely not. Any questions, anyone? Yes, no? Okay. Before we move to the next topic.
No questions.
No questions. Okay. Okay. So let me open another PPT. Okay. Okay. So again, this is an important and interesting thing, and this will really help you to manage your files in the cluster, speed up your MapReduce jobs which are running in the cluster. So at the backend, it will be always the MapReduce, whatever technology you are using, but at the backend, it's just the MapReduce which is getting triggered. So there are two important things which you have to take care in the data. What is in which file format you are putting in the data, and what is the compression which you have enabled on the data. But when you are dealing with such an enormous amount of data, you will be definitely compressing it. If you put the raw data of petabytes or or your zettabytes on your cluster, you are unnecessarily paying the hard disk cost to your vendors, and that does not make sense. So you will be definitely enabling the compression. It's not only the cost, there are other factors also which basically compels you to enable compression. And what are they? So I just want everyone to do a little brainstorming before I go ahead. What do you think are benefit of me as a person to compress my data into the Hadoop cluster, and what do you think are disadvantages of me as a person compressing the data and placing in the Hadoop cluster?
The advantage would be you have more data to store in the same storage space.
Yes. Cost, yeah.
Cost would be
yeah, definitely the cost.
The disadvantage would be we have to uncompress it while we are reading and doing our job.
Yes, high CPU uses.
Right.
Yes. So yeah, these are the two major factors which we have to take care before choosing the compression technology or even the compression itself. So I think I've already told you we can enable the compression at 3 layers or at all the 3 phases in your input files, in your output files, that is from your reducer, and in between mapper and reducer. So at all the 3 places we can enable compression. So if the input files are compressed, the major benefit is your seek time. You would be not only the seek time but the read time also. As you are reading the lesser data, you are doing less IO, so your IO time is reduced. The seek time might be same, but the IO time would be reduced. But as you told, I have to decompress the data, so my CPU usage would increase. So my CPU usage across the cluster would increase if I am using the compressed data. And moreover, when I have to compress it prior putting into the cluster, there also my CPU usage would increase. But definitely the less disk space, so less cost for the cluster. And okay, what are the different compression files? I need to talk about that. So in terms of compression, you are saving on the time when you are reading the data or the IO time, but you are putting more efforts while processing. So you are gaining at one point, you are losing at one point. So you have to figure out how much gain you want to make at a phase, and based on that you would be enabling or not enabling the compression, or you would be choosing different compression techniques. So compression of the output files definitely reduce your disk usage, increase the CPU processing, and set compress output, set compressor class. So you have to. So this is how you can enable the compression at any of the phase. All you have to do is set compress, and the output would change to MapReduce or some or in between phase, and set compression class as your the codec which you want to apply for the compression. So this is how you can enable compression at any of the phase of your MapReduce cycle. So these things would change for different phases, but this is how you can always do it. Sorry, not this thing. This thing will also change. Here the file output format, then input format would be there, or MapReduce will be there. So this is your MapRed compression to enable the compression in between your mapper and reducer. So this is how you can do it. And the codec, I'll talk about these codecs in a minute. So compressing the map output, MapRed.output.compression, by default it false. You can enable it, and the codec and where you want to apply the compression at the record level, the block level. So this is how you can enable the compression at different layers, outputting from the reducer, at the map, outputting from the map phase, and on the input cycle also similar to this, you would use the file input format rather than output format for enabling the compression while reading the data. So these are just the configuration thing which you can do on the MapReduce world. But which codecs to use? Let's look into those things. So before I move into the codec part, anything on the configuration thing, or how to enable compression, or how to use compression at different layers? It's pretty simple. All you have to do is just configuration.set parameter, or you can directly use something like this file output format or input format. Okay. So these are the 4 ones which you will be keep on hearing in the Hadoop world of different compressions which are available. And so the default compression, if in the cluster, is ZZip. The compression ratio of ZZip is very high. You can achieve the compression ratio of 70 to 80% on your text files kind of thing with a ZZip. But if your compression is high, I hope you can understand the CPU usage would also be too high. So that thing you have to think of whether you want to use ZZip or not. So based on the compression ratio and the CPU uses, you might think of different compression codecs. So ZZip and BZZip2 both give very high compressions as compared to LZO and Snappy. But again, both of them would be having high CPU cycles. LZO and Snappy although give less compression as compared to BZZip and ZZip, but are fast because they do not compression much. So there is one more difference, the files are splittable or not. So some of these compressed files are splittable, some of the compressed files are not splittable. I am giving you a minute to think of which compression technology you want to use at which phase. Then I'll ask each one of you, where do you want to use which technology. I'm giving you a minute to think based on this table. The ZZip and BZZip give me very high compression. LZO or Snappy give me less compression as compared to BZZip and ZZip, so their CPU cycles are pretty high, and some of these files are splittable, some of these files are not splittable. So I'm giving you a time to think of and come up with your suggestions which phase I want to use, which compression, and then we'll discuss about these things in detail. Someone was saying something? Karthik, were you saying something?
No, I didn't say anything.
Okay. Hi Amesh, welcome. Yeah, we were missing you. But unfortunately, I do not have your number also. I think you have not sent it to...
Yeah, that's fine because I stepped out and it became late. I got stuck in the traffic and things, so that's fine. It's my mistake.
Okay, sure. Also, you can ping me your number so that if sometimes some problem happens like this, I can try to at least call you.
That's my cell
Okay,
number.
sure.
I will request for the recording of this session.
Sure.
I got all the previous sessions recording.
Okay. So what do you think? Which phase I would be using? Which compression? Which compression does make sense to me? When to use and things like that. Anyone want to comment first?
gzip will be used. I don't think that's very efficient, but bzip can be used for any map reduce jobs which has huge data and has many tasks, many mapper tasks.
Yeah.
That will still be efficient because CPU usage might still be okay compared to the output you are getting, throughput you are getting.
Yes. Okay.
Snappy would be useful when you want to write out a lot of data faster. So reduce tasks can write out Snappy or LZO compression technology.
Okay.
And where CPU is of main constraint and the data files are smaller in size, I think Snappy or LZO should be fine.
Okay. Anyone else want to comment anything?
Yeah, I think LZO LZO is better because you can index the data. Right? At the same time, you are compressing it and also indexing it.
So basically, this file is splittable only if the data is indexed. So there's a property you can index the file, and if the file is indexed, then only the then only the file is splittable. So by splittable, I hope everyone understands now. If the file is not splittable, I have to read that whole file in a single mapper, and if I have to read the whole file in a single mapper, you can think of what I'm doing with the cluster.
Okay. Yeah, I don't know much about this LZO compression format, so I cannot tell the difference between bzip2 and LZO.
Sure. So I think, yeah, Karthik, you also made a good point. And so basically, the ZZzip and BZzip normally people use to put in the data because they give very high compressions. So the real data which I am putting in the cluster or storing in the cluster is very less. Also, when I am using BZzip or ZZzip, as my data is compressed even up to 80% of the real size, I reduces my IOs drastically. So my IO time is reduced drastically because I am reading very less amount of data. So previously, if I am reading 100 GB of data, so 1 GB of data, and as I told you in my first slide, I think on the first day, reading 1 terabyte of data was taking me approximately 42 minutes in total to read it across. And if that 1 terabyte of data is compressed to just 0.2 terabyte of data, so my read time is reduced. So I'm just talking in terms of single node right now, is reduced to just 80%. So ZZzip and BZzip make real sense when you are storing the data or processing the data. So either from the reducer output or when you are really storing it your SDFS directly somehow. So VZZip and ZZZip will give you very good benefits while your data is compressed, not only in the terms of cost effectiveness of your cluster, which your management is paying the cost of the cluster, but also your IO time are reduced drastically. But as the slide says, ZZip is not splittable, so ensure if you are using ZZip big files, you are creating only one mapper. So that is the problem with ZZip. And
what is most commonly used format?
so again, that depends on person to person.
VZip2 is the commonly used format.
Yahoo has moved all its clusters to VZip. Snappy is native from Google. Google is all doing from Snappy. Facebook is majorly working on LZO. So it's again depend on your requirements, your clusters, what you are doing with the cluster. So I told you 3 companies, big shots, all using 3 different. Facebook I'm not 100% sure, but Yahoo and Google I'm sure. But
I will go with Google. Go with which one is used by Google?
So, yeah, but the Snappy is not splittable. So they have Google file system. I don't know what they have done internally, but the Snappy is not splittable.
Oh, okay.
So okay, so LZO and Snappy you would be using up in the intermediate phase from your mapper to reducer. So if you use LZO and Snappy, you are not consuming much of your CPUs in compressing the data. But although you are compressing your data while transferring over the network. So in that phase, people normally use LZO or Snappy to reduce the CPU uses in data compression, but compress it to some limit and to reduce the data transfer over the network. So LZO and Snappy people normally use in between phases, and BZZip and ZZZip are normally used when you really process your data into your disk. So ZZip, as I told you, is natively supported by Hadoop. ZZip is general purpose compression, sits in the so basically it sits at space and time trade-off. BZZip again I've told few more features over here, is freely available. Patent-free, high-quality data compression, typically compress file within 10 to 15% more than 80% of the best available techniques. More effective, its compression is more effective than ZZip. Decompression speed is faster than its compression speed, but it's slower than any other formats because it's doing high compression. LZO compression format composed of many smaller blocks, allowing your job to split your data across the boundaries, but that is only available if your data is indexed, because that information it keeps in the header or somewhere to figure out where to read from. So if your file is indexed, then only your file would become splittable, otherwise your file will not be splittable. As that optimized for speed and are around an order of magnitude faster than ZZip because your compression is lesser. It decompresses about twice as fast as ZZip, meaning it's fast enough to keep up with your hard drive read speeds. Again, because the compression is less, and compress less because it's fast. Snappy is widely used inside Google, is I think created in the Google only. So basically it's from your bed, from Bigdata, which is from Google. So it does not aim for maximum compression, but it's aimed for fastness. As you can see, most of the Google things are highly CPU intensive. They target for faster processing rather than anything else. So that is this again this is again based on the same framework kind of thing. So it aims at high speeds and reasonable compression Compared to fastest modes of zlib, Snappy is in order of magnitude faster. Snappy is also sufficiently faster than LZO for decompression. So these are the different steps, but you have to choose based on these things whether a file is splittable or not and where you want to apply the compression. So probably you would be applying bzip while reading your data or while you're storing your data in the cluster. If your file sizes are big, so terabytes of kind of thing, you would be using bzip to compress a file so that your file is splittable. But your very small file sizes, which is not um, by default good way or good fashion to keep smaller files. But if your files are small, then you can use bzip on those files because anyhow you have different files. So splittability you might not be looking at, but if you have big files in the cluster and big files in the cluster and you want to do a high compression and reduce the reading time, bzip and LZ or Snappy, one of them you would be using up while transferring your data over the network. Okay, one more thing which you have to take care. Now, as I told you, your each mapper, one split, one mapper. So now if your data is compressed, say previously 64 MB of data was really available in one block, but now if I have enabled the compression, high compression, and my data is say compressed by 50%, so rather than, so while I'm really doing the processing on the map reduce phase, I am now would be doing a processing of 60, not only 64 MB data, I am doing a real processing of 128 MB of data on my map reduce. Because I am reading the compressed data and in a split I am reading one block, say, so and when I do a decompression of that block, or that data, my data would be really become 128 MB. So I'm doing more processing on mapper on the same instance of mapper. So again, those things also you have to take care while you are enabling compression of the cluster, whether your nodes have those kind of bandwidth to do a higher processing, whether your CPU is free in the cluster or your disk is usage is high. So you also have to track the cluster resources on your Ambani UI. What is more free in your cluster? Is it the CPU which is more free? Is it the memory, the RAM which is more free while your jobs are running? Is your hard disk is more full? So these kind of things you have to look into the cluster before really thinking of which compression you want to apply. And also, in the first shot, you will never be able to, find out the best compression technology for you in your cluster. It's always recommendable to try and test different things at different phases to find out which one is best suited based on your framework, based on your whole data pipeline. This makes sense to everyone, right? How I am processing more data with help of when I'm compressing my data. Any questions? Anything? Any from anyone?
Nope.
Okay. So We have not looked into Hadoop streaming, so I'll not go over here. I'll talk about this thing, Hadoop streaming. So this is the code of Hadoop streaming. We'll look into Hadoop streaming in a dedicated class. Okay, so yeah, we have some time. Shall we start the file formats? We have time. Okay. Okay, so I'm just silence. I'm assuming yes from everyone, and I hope you are not busy with the match right now. It would take some time to start, right?
It is starting now.
So you want to continue or what?
No, it's okay. We can continue.
Let's continue. Yeah.
Yeah, let's finish it up.
Sure. So let's look into different file formats also. So not only the compression, which you have to think of while storing your data, but the file formats also really make the real difference in the cluster. So the file formats, let's look into a few of the file formats, although there are others also, but these are the few majorly used, and how these file formats really fasten up your data processing and persistence of the data. Let's look into those things. So as I told you in one of the slides, there's something called sequence files. So this is what it is. Let me show you the sequence file, and then we'll read what is written over there. So this is how your sequence files look like. They maintain a header.
Do you have any sample sequence file?
We'll create it. We can create it very easily. But when you will open it, that's all junk bytes. So I'm just showing you the format, but it's very easy to create it. We can create it in a minute. So this is how your sequence file looks like: header and the records, and in between there are sync pointers to sync if your header has lost the way. Header contains your name and keys. Header. Just a sec. Okay, just a sec. Is it better now?
Yeah, only if you keep talking we will know whether there is a blank again or not.
Okay. So header contains name of keys and value of the classes, as well as the compression details, user-defined metadata, compression codecs, and things like that. And your record contains something like this: if there is no compression, the record length, the key, and the real values. And so record length is nothing but your the length of the whole record. Key length is the length of this key only. And if the data is compressed, your record length will contain again the length of the record, the key length, the real key, the key is not compressed, and the compressed value. So this is how your sequence files contain your data. And that's the reason in one of my I was saying the sequence file could be used as a container of storing smaller files. So you can easily put your smaller files as a value and keys to the corresponding value or the name of the file, and you can use sequence file as a container to store your smaller files. be it picture files, be it something else. So you can use these files as those things, and with the help of sync pointers, even if your reader somewhere in between loses its track, it with the help of sync pointers, it can easily sync its position, and it can start reading from the start of the start of a record. So seek files in between, that is with the help of sync pointers. Sync to maintain the block boundaries, block boundary information. Using the sync, you can very easily resync if you have lost your track. Block and record level, both level compression. So what is happening to this guy? And works well for container of small files. So here we did a record compression. Here we did a block compression. So rather than compressing a record, we can do a block level compression also. If you are doing a block level compression, it will talk about number of records in the block, the compressed key lengths, the compressed keys, the compressed value lengths, and the compressed values. So we can enable both kind of compression in these files, not only record level but the block level also. So here your each record in the block, and here is your block level compression. So okay, so let me show you the Umesh, are you still not able to see it, or it's something which you did somewhat previously? You cannot hear me. Can anyone can't hear me? What I did? Can you hear me now? Am I audible now? Now is there any voice?
Yes, I can hear you, but you cannot hear me, right?
Yeah, I was not able to hear anyone. Is it audible to everyone? Just say yes or no. A quick yes or no would help me. Okay, so Karthik says is going to go worse as the match gets interesting and the more people start streaming. Okay. 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 Okay, so Umesh says it should be a logical stop. Okay. Okay, then do you want to stop now? God, must be crazy. So do you want to stop now? Yes, no. Okay. So Chan says yes. Okay. What about others? I don't know. Or we can continue this. It would take around an hour. Okay. Okay. Okay, so as every one of you are saying to stop right now, I'll. So is Umesh only can't hear me, or it's, I think everyone can hear me. Umesh, I am not sure whether it's some problem with your end. Everyone is able to hear me and they can respond to my questions. His voice is completely off to everyone, or is just for the Umesh? Okay, I'm stopping for today and